Okay. Good morning, everybody. Welcome to Track E, Leadership in Action. I'm Bob Audette, Partner Lead for the Data Management Practice at Guidehouse. I have a distinct pleasure of kicking off the session, focusing on a topic that's quite relevant these days, the GPT effect and how that's redefining data strategies and platforms, and with advancement of generative AI. And Mark Ramsey will be really leading this session and sharing some interesting insights. Prior CDO of GSK, longtime speaker here at the symposium, and a couple logistical things. The session will be recorded. It'll be available 3 months from now on MIT's YouTube channel. With respect to questions, for those attending virtually, please use the Wahoo app, and we will try to get to your questions in the time allotted. For those in the room, I will come by with the mic and ask you to just introduce yourself and where you're coming from, and we'll get to your questions. So with that, Mark, take it away.
Great, thank you. You folks picked a good session because when I did this yesterday, we had an overflowing room. It felt like 100 degrees in there with all the people jammed in, so they asked me to do the session again, and so it's a little more comfortable today. So I know a lot of folks have heard about GPT-4 and ChatGPT. I mean, it's like you look anywhere in any news article, you're going to hear and see things about that. My real purpose today is to kind of go through and a little more practical and talk about the way that the technology works and maybe demystify it a little bit, and then talk about why using GPT-4 can really have a big impact on the data strategies within organizations. It can be both to help challenges that we've faced in leveraging data as a strategic asset, but it can also be the things that we will need to think about in order to support these types of initiatives within the data strategy. So just a little bit about myself. I've been focused on data and analytics for about 35 years. I was the former Chief Data and Analytics Officer for GSK for a number of years. I was the Chief Data Officer for Samsung Mobile. I spent about 20 years with IBM focused on working with clients around data and analytics, and then before that I built some of the first data warehousing solutions, back when we used to call it data warehousing, for insurance industry. So I've kind of been in both the industry side as well as the consulting side. And in 2019, after finishing the work at GSK, I brought a number of the folks together that had worked on the GSK program and formed an organization called Ramsey International. And we focus on working with clients on deploying these kinds of solutions. There's a couple of things that we've created. One is called Dataless, and that's an automation solution to deploy large-scale production platforms. And then we've also, over the last year, been working on a solution that allows enterprises to deploy GPT-based chat interfaces, and that's what we're going to kind of use as the backdrop of the kind of the process that we went through and some of the things that you have to deal with when you're building these kinds of solutions. So looks like a lot, but I'm going to try to keep it pretty crisp here. In the middle, I'm going to do a demo live, but what could go wrong, right? It's emerging technology on a hotel Wi-Fi network. Nothing can go wrong there. So I'm going to take that. I guess I like the risk of kind of just trying to do all of this. So we're going to talk a little bit about the background of OpenAI and the GPT technology, talk a little bit about something called an embedding, and then how to actually use an embedding to help improve the use of generative AI. And then I'll do a demonstration of kind of how all of this fits together, just to kind of give you a sense. I mean, I know folks may or may not have gone into ChatGPT, and if you haven't, I'll be showing what that kind of looks like, and kind of talk about, I know there's a lot of discussion around should you even use ChatGPT, and are you going to run the risk of disclosing your company's information and all these kinds of things. And we'll kind of talk a little bit about that. But I also want to help you understand the separation between the power of the GPT model and what it can do from the available data that is in the base model, and what it can or cannot do, so that you have a perspective on that. And then we'll kind of talk about challenges and limitations and risk management in the future and all that. So that's what we're really going to accomplish over the next hour. So GPT stands for Generative Pre-trained Transformer, which basically is a mouthful, so that we all just call it GPT. And it basically means that they've taken a lot of data and built a very large model that allows us to have conversational interactions and make it feel like we're kind of talking to a human when we're actually interacting with a predictive model. And fundamentally, it's based on a technology called neural networks, which is based on kind of how the brain works. So there's different connections, and that the information is brought together in that way. So this is not brand new. It started in 2015 with an original transformer model, and the transformer was very, very specific to very specific problems. So there was a whole collection of different models that some would work on text, some would work on images, some would work on different types of content. In 2018, there was this first iteration of GPT-1, which, compared to the publicity that is out there on the GPT-4 model, you probably didn't even know this happened in 2018. It was a very kludgy way to operate, but it was kind of continuing the process of this whole area of natural language processing. So again, you could interact with the model in text, and it would make it feel like you were having a conversation. Now, things continued to progress with the next iteration, and then finally in 2020, there was the release of the GPT-3 capability. And again, this was a very large expansion technically, because you can see that it contained 175 billion parameters. And kind of what that means is that the way I think of it is, like I described a neural net as these connections in the brain. Kind of think of it as they now have a model that has 175 billion connections and the ways that things can traverse between that model. It's a good way just to kind of think of it. And then in 2022, there was another iteration that was, again, focused on kind of iterations around how best to interact with the model. And quickly, 2022 was where ChatGPT was released. And ChatGPT was basically the first kind of UI or interaction where you could type a question, get an answer, and behind the scenes it was executing this GPT infrastructure, right? So, and this picked up a little bit more publicity, and people were interested in it. And you can see that ChatGPT reached 1 million users in 5 hours. If you think about Netflix, it took 3.5 years to get to 1 million. Even Instagram, I know this is a bit of an eye chart, but Instagram was the next fastest, and it took 2.5 months to get to 1 million users, which is pretty interesting. Also, given the fact that OpenAI actually was capping how people could subscribe. So they couldn't handle more users, so they limited it, and within 5 hours they'd maxed out. So if you think if that was unlimited, this number could have been how fast it was to get to 5 million or 10 million. So they've been struggling to try to keep up with the underlying technology to really support this. But it's still pretty amazing that in 5 days, I said 5 hours, sorry, but in 5 days they reached 1 million users. Then March of this year, seems like a lot longer ago if you think about all the publicity that's been out there, but in March is when they released GPT-4. And some would say I'm pessimistic on new technology, and I think things get overhyped. We all remember the big data era, which is really marketing more so than actual reality. This, I can tell you from my perspective, is different. The release of GPT-4, we will look back on it in maybe 4 or 5, 10 years and say that this was an inflection point in the world of technology. So don't underestimate the capabilities of what's released with this level of this model. So I would say the release of the internet and the adoption of electronic commerce in the 2000 timeframe was the next, but I would put this above even that. And for two reasons. One is what capabilities it introduced is broader, but also I think the adoption rate is going to be much, much faster. If you think about electronic commerce and the internet, I remember back in those days we would say, oh yeah, we can sell books online, but nobody would ever do banking. If you fast forward to today, everything we do is really tied to the internet. There's a couple of things here that you may have heard that I want to kind of give you a little construct or context around. Like the fifth bullet down, it says that GPT-4 has an 8,000 token context. So first of all, a token. A token is a subset. It can be a word or it can be a subset of a word, but kind of think of it as it's breaking long words into pieces. And even if you just think of it as about one word, you're kind of good. But it gives you a sense that even if you say 8,000 words, 8,000 words is maybe 4 or 5 pages of text. You can see on here that there's an advanced version that has 4 times that is 50 pages. So if you kind of mentally say, well, then that means that 8,000 tokens is about 8 pages. I think it's a little bit less, but you're limited in the interaction that you have with the model. And the reason for that is because it takes a lot of processing to go through all of those tokens for the model to respond. And the more context that you send, the more requirement it is of actually executing that and progressing through the model to give you an answer. And context actually means your full conversation. So when you ask a question, more than likely you want to get an answer back. So you have to allow tokens for that. So the example that I'll show you here in a few minutes, we allow about 1,000 tokens for the answer. So then suddenly we're down to 7,000 tokens for the communication. So what you're, and folks have heard of this thing called prompt engineering. That's a fancy way to say all of the information that you provide the model before you actually ask your question, right? So the question could be, who is Mark Ramsey? That's pretty short. That's probably 10 or 12 tokens. But I want to give the model other information before I actually ask that question. And that together is the prompt. So if it was just as simple as saying, who is Mark Ramsey, then I would be giving about 10 tokens and I would be leaving 1,000 tokens for the answer. So then I would have, the rest of it for things that I could provide. And I'll take you through the exact scenario because the fact that the model, because it takes so much time and energy, it takes, a very long time and it's very expensive to train the model. The knowledge in the model is limited to September 2021. So the model has not ingested anything since then, right? Because it takes months and months and $100 million plus to go through a training cycle. So the model doesn't have current information. It has information up to September 2021, which is why if you ask it a question that happened prior to that date, it may or may not know, but it won't know anything that's happened after September 2021, which means in order to get a valid answer, in addition to giving it the question, we have to give it information to help it answer the question. And the reason I'm kind of going through all of this is all of that has to fit in 8,000 tokens. So I can only give it so much information to consider, the question and the kind of the training messages, if you will. So in the solution that I'm going to show you, these are some examples that we include with every interaction with the model. Everyone's probably heard of something called hallucinations, right? The model is bad because it hallucinates. Well, it's a fancy word for lying, but it sounds better if you call it hallucination. But the model like this, it doesn't really know what it is saying. So it's not lying, it's just giving you back information that aligns to your question, but it doesn't know if it really is the answer or not. But it almost like it wants to answer the question badly enough that it's giving you this But that is something that's customizable, right? So the way we train the model or influence the model is this statement that says, always strive to provide truthful answers, and if uncertain about an answer, please respond, I'm not able to accurately answer the question. If you add that, it actually influences the discussion, so instead of coming back with what it thinks is close, it comes back with, I can't answer the question, because think of it as you're giving it this information to consider as part of its answer, which it then does. The other thing is there's another dimension in the discussion that's called temperature, and that is how creative the model is. So we set the temperature to 0 because we don't want the model to be creative. Where you would want the model to be creative is if you want it to, every time you ask a question, it's going to get a slightly different answer, that it gives you different, like maybe if you were wanting it to be unique in the way it's answering, but that also, the downside to that is that it gets creative. So you get what you ask for. So, and I'll show you how all this comes together. And so these are the ways that you're actually, think of it as like you're educating the model of how to respond. Again, these messages come out of the 8,000 tokens. So one might think you could just come up with all these messages and it would make it so much better, but the problem is everything is a trade-off. So you have to be efficient on the messages, and that's this concept of prompt engineering. And so that's kind of all the background of GPT-4, a little bit on the tokens. The way I think of it, and I would encourage you to consider thinking about it this way, is GPT-4 breaks into two pieces. The reason it is so well-versed in the conversation is because of the fact that it's been trained on probably trillions of dimensions. That's all this content that it's loaded, right? So, but that is helping it understand how to communicate back and forth and the nuances of the question. So that's taking it, like if you view GPT-3 as a 5th grader and GPT-4 is a PhD level, that's in how it communicates. That's one piece of the model, and which I think is the most powerful piece. The second piece is the knowledge that it's been trained on, that you can ask it questions. I think that's less important because when we build real solutions, especially for organizations, you want to give it the information to consider as part of the answer. You don't want to rely on what it's been trained on. So, and that's really one of the important differentiator between when you're playing with this technology on ChatGPT and you're building an application for a company. When you just go into ChatGPT and ask a question, it's novel and it gives you an answer, but when you're building it for an organization, you will want to provide it the context to then make a decision and give you an answer within the bounds of what you're providing. So you just have to get really creative of how you do that. So how do you do that? That's what an embedding is. So an embedding is taking the knowledge that you have within your company that you would like the GPT-4 model to respond with. So you're feeding it the content. So let's say, for example, if you think about, I don't know, pick a PDF document that you have at home, or any topic, doesn't matter, but you have a PDF document, it's 20 pages long, and you want to ask questions about that document. And I'm simplifying this down just for the example. I mean, it could be thousands of PDF documents, but let's just think of one document. That document is 20 pages long. So an embedding is that you take that content and you break it into pieces, which are called chunks. And then you go through a process that's called vectorization, which is basically taking those chunks and turning them into numbers. So whenever you hear this thing of vectorization or vectorizing, it's taking the text and turning it into numbers. And the reason we do that is because it's much faster to deal with numbers than it is to deal with trying to do text searches. So when you vectorize these chunks, like it shows down here, right? Cat, dog, apple, strawberry, it creates these series of numbers. In the case of the OpenAI models, there's 1,536 numbers for every chunk of text. And those numbers are the numeric representation of the conversion of the token into a number so that you can then do really fast math to determine what's close and what content matches your question. So we take our PDF document, it's broken into chunks, and the reason we break it into chunks is because we're limited to 8,000 tokens, so we've got to figure out how to take the chunks that are most appropriate. So we can't just vectorize the whole document because it'll be much bigger than what we can use in our interaction. Plus, if you think about it, if you ask a question about your document, it isn't the whole document. It's one little section of the document or maybe 5 sections of the document that need to come together, and that's what we're going to be doing through this process. So we take our PDF document, break it into chunks, we vectorize the chunks, it becomes the numbers, and that's what we store in a vector database. So if you've heard, oh gosh, if you're using large language models, you're going to be using a vector database. A vector database is just a type of database that it stores these numbers, and it's really efficient at doing similarity searches. And so that's how we kind of, all this process happens as a batch process, to get ready for, building our solution. So we take our document, we break it up, we vectorize it, we put the vectors into a database, and so those are now ready to use as part of our chat. So what I'm going to show you in the demonstration is what I just talked you through is the preparing the embedding. So we take our PDF, we do all that work. Now, when we ask a question, what happens? So I ask a question like, who is Mark Ramsey? The first thing we do is we take that question and we vectorize the question. So that sentence becomes a series of numbers. Then we go and we ask the vector database to give us, 10 chunks that are most closely aligned to that question. So if we're thinking about our PDF document, if my name would show up in that PDF, it would bring that chunk back as something that was relevant to the question. Then it comes back, the text of those chunks is then packaged up in our question, and then we push that up to the model and say, this is content that you should really consider to answer the question. Then what the model does is it takes all of that text, and then it takes the question, and it determines how to answer the question based on the text that we're providing it. Does that make sense? The trick is 8,000 tokens, right? Or whatever the number is. They're 3,200, whatever it is, but you can only interact with as much text as you can, but you can do that really efficiently. So that's how that process of embedding works. And if you've investigated all this or you've worked with it, there's other ways to do it, like it's called fine-tuning the model. The problem with that is that you're actually modifying the model and you got to do a bunch of other stuff. So embeddings has really become the way to get the model to answer the questions efficiently. Okay, I'm going to attempt to demonstrate this. I think it makes a little more sense if I kind of show it. We'll see. Like I said, what could go wrong? Okay, so how many folks have actually played around with ChatGPT? Okay, everybody, right? So I'm sure the first thing that you did was you put in who is, and then filled in your name, right? Anybody do this? Find out what it knows about you, right? Everybody. Come on. You either didn't tell me or whatever, but. Yeah, and part of it is what gets loaded, right? So, so you notice it took a little while, right? Part of that is because everybody in the world is pounding on ChatGPT anymore because they're trying to answer every question. And how many people think ChatGPT is just a fancy replacement to Google, and that's what people are going to use it for? Okay, good. Thank you. So here you go. I'm a Canadian boxer. I'm an American football defensive tackle. I didn't even know I did that, or I'm a radio broadcaster, right? So Okay, so it doesn't know much about me, which is a little disappointing. You know, I was saying, you know, it knows all this stuff about September 2021, and I've been doing this since 1985, and it's like, I don't even make the list. But I'm sure if you folks do it, your names will show up. What is Dataless? Because you remember I told you that we developed this solution called Dataless. So you're always kind of hopeful that, you know, what you built kind of made the grade or whatever, but what we'll find out, unless something magically changed, what we'll find out is Daedalus is a Greek god, which is why we named the solution after that, is because it's a god of architecture or whatever. And so, it takes a little bit of time. There we go. So I'll scroll up so you can see that Greek mythology, craftsman and artisan. That's why we named it that way. Okay, so that's because that separation of the way it communicates and then the knowledge that it has, right? That separation. How many have heard that you should never use ChatGPT because it discloses all your data and it incorporates it into the model, and that Samsung lost their firmware by putting it in? Anybody heard this? Yeah, okay. It is actually true, right? It's the same as, does anybody use Google? And I'm sure you all turned off the setting that says never track me, never keep track of all of that. Of course, then the trade-off is it never tracks you, so it never knows where you are, it never knows where you've been, and you're like, ooh, have I been to this restaurant? If I just turned it on, I would know. But so everything is a trade-off, right? So if you do want to use ChatGPT and not have that happen, just quickly, if you go to settings here under data controls, and you can turn off the history and the training. If you don't do that, what happens is the questions you ask get logged on their system and they use it to improve the model. So potentially you're disclosing the what you upload. Like if you would upload data and say, look at this code and give me an answer, you would potentially be disclosing that. If you don't want to do that and you still want to use ChatGPT, just turn this off. The other way to do it, which I would highly encourage every organization, is to use the APIs. Don't use ChatGPT. I would encourage an organization not to have folks in their organization using ChatGPT because there's no prompt engineering. You can't put guardrails around it. It's kind of a little bit the Wild West. But if you build a solution and then call the APIs, the data is not used in the models, and it's ephemeral, so it doesn't get stored. It's gone. So.
There's a setting in the API usage.
No, here, if you're using ChatGPT, this is the setting. On the APIs, nothing is tracked. There's no setting. It's just...
You need to actually ask for it for your account.
Actually, we can talk about that, but no. With the APIs, that's... And again, you're trusting that they're executing all of that, but I'm not going to get into that piece of it either. So, but... All right, so... Now, let me switch over, and this is the chat that I described, the RI chat that we built. And I'm going to just show you kind of the art of the possible a little bit and the way you can think about it, and how that, you know, that whole process that I described, show that actually working. Because when I talk about it, people are kind of going, wow, that's, you know, you're going to ask a question and then 3 hours later the answer is going to come back because all this stuff that you have to do. Actually, that's not the case. So I'm going to ask the same question again of who is Mark Ramsey. And this time what happens is I go through that process where the question gets vectorized, embeddings get pulled, we feed the content up, it answers the question, and voila, now, you know, here we go, right? So because of the fact that we're giving it a collection of content to use in the answer. Now, the other thing that's nice, if an organization is doing this themselves, you have the choice. You can say, don't use any of the trained knowledge, only use what I tell you, and answer the question based on what I give you, which is current source kind of stuff. Or what we have done is we say, look, use the current sources as a priority, but still incorporate your vast knowledge. So it's coupling those two things together. So you're getting the advantage of all of the knowledge that's out there, coupled together with what you're giving it as a way to improve the result. Regardless if you do that either way, the the style of communication and the interaction is going to be at a extremely high level, right? This is where when people say, oh, don't use GPT-4, use a local model because then you're not having to send your data off and all that. That's great as long as the local model has any level of performance anywhere close to GPT-4, right? This GPT-4 is exponentially better than any local model today. Now the models today will get, I mean the local models will get better, but it's apples and alligators when you're comparing them. So that's why we really encourage folks to determine how they want to make use of GPT-4, even if they have to be creative on what data they send and how they send it and all of that kind of stuff. But the level of communication, if you're asking a local model a yes or no question, it doesn't really matter. You can use a local model, you can use an older model, but if you're really wanting to have a conversation and you're wanting to do a lot of more extensive things, you need to do that with the GPT-4 model. What is data list? I'm just doing the same questions just so you can see the difference. And again, it now knows, but you can see that this is much faster than me asking ChatGPT, right? The reason for that is everyone on the planet is pounding on ChatGPT. This is using the APIs, but just to reiterate, we ask the question, we make an API call to OpenAI to vectorize the question, like what is data list? We make a call to Pinecone, which is the vector database that we're using to get the top 10 or 12 or 15 responses. We're packaging those up. We're making a call back to OpenAI to the GPT-4 model to say, here's current source, answer that question, and then it's responding with the answer, and that's what's being displayed. So those steps are all happening in real time to get to this. So, and I would say that it's probably 2 or 3 times faster than just using ChatGPT. So that's the other thing is sometimes people think, oh, if I just use ChatGPT, I mean, it's $20 a month if you're doing ChatGPT Plus. This is based on your token count back and forth, but you're talking about, cents, very small transaction fees to do this process.
So when you said that your data... So just a small question, sorry to interrupt. When you said that you trained their model, you sent it to the Pinecone and everything, the data lives on, because I see the server there is yours. So
well, that's just the website.
Yes.
Yeah, that's just where the
What
server's
are you
running.
calling the APIs, right? Where you're hosting this application to call the APIs.
Yeah.
But when you said that, the data that you train goes into Pinecone, I mean, where it's vectorized
as
and all.
an example, right? So what happens is you vectorize the chunks, and the text and the vector goes into Pinecone. And if you care, you can encrypt the text. Like we have a setting where you can encrypt the text that you're storing in Pinecone.
Okay.
But those chunks, like let's say 10, right? Let's say there's 10 chunks of data. Those 10 chunks of data have to go to the model at OpenAI in the clear so that it can build an answer. There's
Got
no
it.
magic to encrypt it at that point, which means that if you have sensitive data, like let's say you're wanting to interact with customer data and you don't want to send that to OpenAI, then you have to introduce something in the middle, like calling a local model to summarize the text into something that you then do feel comfortable sending. But the way this is designed here, and the example that I'm showing you, it's encrypted in Pinecone, it's being sent to the model, like 10 chunks of data. It's using that to create the answer.
Thank you.
Does that answer your question? Yes. Okay, yes, sir. Actually, can you hold it? Okay. Happy to talk about it or whatever, but I just want to make sure we get through. So also one other thing, and this is just an awareness type of thing. You notice like when it answers the question, it looks like a teletype, and it kind of trudges across. That's the model generating the next token, and what we do is we stream that to the screen, which is kind of cool because it's almost like the brain of the model executing, right? So it's like, and sometimes it goes faster or slower. It's because of the performance of the model happening. What we've found is from a customer experience perspective, starting to get things back quicker, people are like, they would rather kind of read it through, as opposed to wait till the whole answer's done and then just flash it up on the screen. But that's what's actually happening in the background, which I actually think is kind of cool if you think about it, because it's that multi-billion dimensional model that's going through. And again, it's not thinking about it. It's using math to determine what things assemble to display to the screen. Okay, so the other comment is we talk about chats as interactive, right? You want to ask follow-on questions, right? Just like this gentleman was trying to do before I shut him down. But the way that works is like if I would ask a question like, so I asked Daedalus, I said, whatever, as a follow-up question, guess what? The only way that works is that we take the question and the answer and we include that in the context that we send back to the model. Because the model does not retain history. It doesn't know that I just asked this question. When I go back to the model, the slate is clean unless I include it in the context. And we all remember what? 8,000 tokens? So I need to take those tokens and include those in the discussion in order for it to have that context. So you have to get creative on some of this. And what we've done here is we include history, but if the history causes those embeddings, we actually call the model to summarize things down. So if we have, let's say we have 4,000 tokens worth of current knowledge that it used to answer this question, and then I ask a follow-on, and I can't put 4,000 tokens in, I can only put 3,000. Before we send the question, we actually call the model to say, summarize these 4,000 tokens down to 3,000 tokens so that I can then include it in the context. So it's like layering of this on. And that's the thing, I always laugh when people say, oh, it's just Google. So you have to be really thinking about how you can take advantage of the model to continually help you do even better. One of the things that you may see it like up here in the corner, as soon as I submit a question, it comes up and says checking the validity of the question. That's because it drove me crazy if I type like 11111 and hit enter, it would try to tokenize things to answer a question that was 11111. So to eliminate that, we actually call the model to say, is this a valid statement, before we go through the process of pulling everything out of the vector and doing all of that work. So we're using the model to validate the question or the statement before we actually submit it. And then I could do something like, what is this? Daedalus does. Okay, so if I say, how does it help deploy CDP? Then it's going to factor all of that in, and what is it, right? If I just say it, so now it knows that I was talking about Daedalus because that was the question I just asked. So then it gives me extended information on the it, because as humans, that's really common for us, right? We ask a question, we get an answer, we ask a follow-up question, and we reference it not by saying the name over and over again.
You built that into RI chat.
Yeah, it's in GPT. History is there. But this is we built it in here, but we also built in the capability to turn it off. Because if you turn off history, then you have one-shot questions, but you're getting the most content, which gives you the most granularity in your answer. Okay, so all that's cool and fun, exciting, and it's whatever. What about enabling the model to help us do like real things? Like not answer questions, but like actually do stuff, right? So one of the things we wanted to do, because we do a lot of work with the Cloudera platform, what if I want to know what's going on there? Like what are our current CDP environments? Now this is not in our content, right? I've not loaded this in batch. I want to know this in real time. And so what it does, and it happens so quick before I could even describe it, but I will take you through what just happened, right? So I asked this question. It goes to the model with the question. We've told the model that if we're asking a question that relates to the current Cloudera CDP environment, we've created a function that helps answer that question, and you need to tell us what you would like us to ask CDP. The model creates the CDP command that's required to execute to get the answer, and then it comes back, but it doesn't come back with an answer. It comes back saying, call this function and execute this action and give me the answer. So what happens is this web server calls that function with the query that was provided by the model. It executes it, it gets the answer, and it sends the JSON information back to the model and say, here's the data to use to answer your question. And then it reformats it and it says, okay, you've got this RI environment, whatever. Because the model can be really good at writing things. Like in this case, it's actually writing the CDP CLI command to answer this question. Now, what about data quality and things like that? So we've also integrated with, there's a company called Modac. They have a metadata-driven solution that acquires all this metadata and puts it in a SQL database. So we've created a function that I can say, what are the databases that contain SSN data? Now, before I push enter, just so you can see it, upper left corner, it says waiting for query. So when I hit enter, it's going to say validating the question, then it's going to say answering the question, then you're going to see it flash up saying call a function, then you're going to see it give us an answer. And I took you through the process of what's actually happening, but the model is creating a SQL statement that it's sending down to say go call this function. The code's calling the function and then getting the data back, and it's reformatting all of it. So it's just to kind of give you a sense of you can extend this whole environment, and the model can help craft a lot of these things. So answering the question, calling the function, and there's the answer. And you can see how long that takes, right? So, but that's all the stuff that's happening behind. And also, don't get me wrong, we still did the embeddings. We still sent all that up because the embeddings, and this is something that's kind of cool, is the embeddings this time were actually the SQL statement packaging of what was necessary. It sent like the schema of the databases that are going to be queried. So you could use this type of approach to query your customer database and say, what are my top 10 customers that do whatever? And then that gets fed back into the model. It answers the question. All of that can be a process, right? Okay. We're almost there. And so the other cool thing, again, I think it's cool. I'll leave that up to you to decide. But this whole embedding process and all of that, I kind of think of it as you're giving the brains to the model to then actually answer the question. And in this particular case, the personality or the brains that we're answering questions around it's all based on like modern data management kinds of things. And so let me ask this question. What is MS? Now, if you're like modern data kind of thing, what would you think MS would be from a data perspective? I would guess it'd be Microsoft, right? So, guess it's a technology company, right? But what if that's not what I'm interested in? And we've had the fortune to work with a lot of life sciences companies. Life sciences companies don't care about Microsoft, right? So the sources that we loaded into the vector database up to this point, what we've been talking about, have been this modern data environment. But what if I want to pull out that personality and I want to switch personalities to something that's more pharma? So I'm going to change my personality to pharma and ask the same question, right? What is MS? And now what happens is that process, it's going against, I call it a personality, but it's actually a completely different vector store that's been loaded with pharma data, and now this is what MS relates to, which is more appropriate. So the thing that I want you to leave with is, like if you're building something for an organization, you can have different personalities for different parts of the organization, because you wouldn't want, like let's say you want to load a lot of sales information so the sales team can ask questions about the sales and say, who's my best client, blah, 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 or whatever. You don't want that commingled with finance data, right? Heaven forbid that the sales team gets access to the finance data or whatever. So it gives you that ability to completely isolate. And I kind of think of it as unplugging the brains and plugging in another brain that is very trained. And literally what I did to do this was I took some basic information like genetic information, disease information, and just vectorized it into the database. And so it's pulling all of this together. I can do things like, let's say, what gene is associated with the most number of diseases. And so obviously that's not a modern data management question. That's, and see here it's like, oh, unfortunately I'm unable to provide an answer at this time. So there you go, just to demonstrate what happens in a live demo. But the idea here is that the content and the source that you're going after, you can isolate based on different kinds of things. So let's switch back to the presentation, and I've got a couple of things to share, and then we'll open it up if you have questions. So we talked about a lot of these already, but I wanted to give you a list, a hit list to use. The hallucinations, they lack the event after a certain period of time, and I kind of touched on all of these things, and also, you know, even though these are normally brought up as limitations, you know, actually we kind of hit on why you can overcome a lot of these things. The one that I always love, and I'll just touch on it, I mean, the non-reproducibility kinds of thing, this is not a predictive model. This is not a model that you give it data, you get a prediction. This is not a cross-sell model. It's not an upsell model. It's not a credit scoring model. This is a conversational environment, right? We didn't talk about, you know, doing predictions on who should I target for certain products. I mean, that's not what this model does. So I mean, AI is great, machine learning is great. GPT-4 is transformational in the conversation. It's not an impact, it's not a predictive model, so don't use the wrong tool. Now you could, like I showed you, you could add functions that do those things and then provide the conversation engine with a way to write a letter to a customer to say, sorry, we've declined your request for funding because your credit score is not good, but you don't use the model to determine the credit score. So it's, people get sometimes confused around that. Hallucinations, I had a little doodad here. Yeah, it hallucinates, but you can put guardrails around that. The large language model is not good at math. So you can ask it math questions, and it will try to answer math questions using text for its decision. So again, you don't use the wrong tool to solve the problem. And that's why there's extensions that can, you know, drive things in the math area, but the model doesn't have that capability. You know, again, back to using the right tool. And you can also mitigate these risks. You know, you can put guardrails in place, and that's why we really encourage folks to have standard messages that are part of every prompt that you send, right? Like that whole thing, don't lie to me. You know, you can say, don't say bad things about this, don't do this, don't, you know, there's, that you incorporate that into your messages to make sure that it's responding in a way that is appropriate for your organization. Because we don't want to end up on the front page of the Wall Street Journal, you know, so that's why you would most likely, I encourage companies not to, you know, deploy ChatGPT, the vanilla version, to their organization. You know, put something in front of it so you can control that interaction and make sure that it provides appropriate responses. And then, you know, we've got tons of things for future opportunities, right? This will continue to expand. There'll be tremendous capabilities as we move forward. But start thinking about how you can use this type of an approach to address a lot of the things that we haven't done a very good job of in the whole data strategy area, right? So converting things from unstructured to structured data, you know, leveraging ontologies on top of unstructured data, categorizing things, summarizing things, cheating at writing college papers. I mean, it's all, the sky's the limit on the things you can, but no, I mean, it's just, we can apply this technology to so many things in the data strategy area. Don't lose sight of the power of using the technology to help us have better data assets don't get too enamored on the downstream applications, which that's a tremendous opportunity, and that's where big value is. But we can actually use the technology to help us improve. So like that example I shared, which was where are the databases that contain Social Security number, we can use those kinds of things to really optimize and make it easier for improvement of the data assets that we have. So it's using it on both parts of that equation are going to be important. There's all my contact information, although I'm in LinkedIn and on Woo, all that. Anyway, any questions? And we just want to make sure Bob gets to you with the microphone. And I know we probably may or may not have some questions online as well.
No questions so far.
Thanks,
Okay,
Bob.
good.
Hi, Mark. This was
Hello.
great. I'm Prashasti, ex-Silicon Valley Bank. I had a quick question. I know I tried ChatGPT to put a graph or like an image to understand the details inside. So like, you're a human and you're not a computer, where they say how many bridges are there in the sixth picture. Something like that. If I upload a graph and want to get a summary of it, does RI interface account for it? Like anything outside, any prompt outside of English language text?
Yeah, I mean, the other images are a slightly different animal.
Yeah.
So that's not
Graphs
something
or-
that we've
yeah.
really tackled at this point, because most companies are in the walking stage and not yet trying to really process that level. It's not a big change. As far as English language text, I mean, it supports any language, because the model, I mean, if I want to ask a question in English and have an answer in French, that's literally, you can make a change to the messaging and it does that. Or if you want to query a database that's in English and have the answer come out in Spanish or whatever, you can easily do that. That's actually prompting messages. So, I mean, that's the thing. It's like just blows your mind away. Is literally to have that happen, you just ask the model to do that when the question flows. So, like the system messages that I had up, we could change that to say interact with the user in Spanish. But then behind the scenes, it's going to write a query and get an answer in English, and it'll just know it has to translate.
So you're treating graphs, bar graphs, all as images at this point, too,
Yes.
kind
Yeah.
of. Okay.
Yeah. Although the nice thing about the GPT-3 and 4 is that it's a commingled transformer, so it can handle all of those. So the model can actually handle images and all bar charts and all those kinds of things. You had just asked it what we had done thus far, and that we at this point have not tackled that. We haven't had an opportunity where anyone really wanted to do it yet, but the model itself supports it. So it's just what kind of questions you're trying to answer. It's kind of interesting as a sidebar is that a few years ago I had a patent on analyzing images from hunting cameras. And back then we had to use convolutional neural networks to try to understand what was in the image. And now I look at this, and like in 10 minutes I can replicate everything it took me hours and days and weeks to do, and the level of quality is 100 times better, and the effort is minuscule. I mean, it's just amazing. So anyway.
Thank you.
Yeah, you're welcome. Thanks.
Hey, I'm Mark Johnson from Accenture Federal Services. So I had a question about the switching the brain from one to the other.
Oh, the personality? Uh-huh.
Yeah. So the question was, did you make that decision because you weren't able to give it the context and the prompt to say MS in this field? And then the second for that is, when you do that split of pharma versus the other, is that siloing it so that it wouldn't be able to kind of find context cross domains of knowledge?
Yeah, you actually answered your first question with the second statement, right? So we did it to isolate as an example.
Yeah.
So we could have easily put all that information together into a single repository, and then the model could have differentiated based on context what it thought we were asking. And you might remember at the beginning when I asked it about myself, and it said, well, it could be a boxer, it could be this, it could be that. If I would have asked ChatGPT about MS, it would have actually said it could be multiple sclerosis, it could be this, it could be that. That's the answer we would have gotten without the isolation. And so we actually wanted to demonstrate how organizations may want to, I'll use your word, silo the data. I use isolate so that it doesn't commingle, right? Because if I go back to my example of like the finance department and the sales department and the HR department, you may want to have one experience on the way you interact, but you may want to isolate the data sources so that when someone asks a question, it doesn't use all of the sources to answer the question. So we did it by design, but if we had not done that and we had loaded the pharmaceutical data together with the modern data management data, then we would have gotten an answer most likely that it would have said it could be this or it could be that, but it couldn't distinguish. Or if we had just asked a scientific question and left the history on, then the model would have assumed that we meant a follow-on to scientific information. Does that help?
Yeah.
Yeah, so we kind of did it on purpose, but you can do it both ways. It's more of a decision around what benefits you're trying to see.
Yeah, thank you.
I just had a follow-up to that. So does the model, either your RA-Chat or ChatGPT itself, I don't think ChatGPT does, but like, is there the ability for the model to ask the user clarifying questions? So for example, the example that this is bringing to mind, my brain has had to make this switch. I'm a physician who ended up joining industry, who ended up now going into data. So the example I've used several times
Well, it
is,
took you long enough. Why
Yeah,
did it
I
take
know.
so long to get to data?
So the term GFR, when I first started my job at Express Scripts, very focused on generic prescribing, I couldn't figure out why everyone was so worried about everyone's kidney function, because in my previous world, GFR meant glomerular filtration rate, which is a measure of kidney function. But at Express Scripts, it meant generic fill rate for prescriptions. So our human brains have to make those same kinds of switches with
Right.
acronyms and other words, but it would seem that it would be valuable if the model, because those are both in medicine, both in healthcare, if the model could say, hey, you're asking about GFR, are you talking about kidneys or are you talking about prescriptions?
Yeah, I mean, right now we don't ask clarifying questions, although that would again be similar to the execution of the function, where if you can't ask if you can't answer it in a certain way, then ask a question. So that is something that we're actually actively looking into, and it should be pretty straightforward. What would happen though is if you said something, if we had more repository, because I have a pretty small sampling of data, but if you asked a broader question about GFR, it would come back and say GFR could be one of these two things. Which do you mean? And then you say, well, I mean number one. Because we've sent it the history, then it knows you mean kidney function or refill rate, and then that's why it's important to have the history. The problem with history is that each time you go through the iteration, you narrow the context window, right? So with GPT-4, they have released a 32K context window, and they're expecting to release one larger. There's another competing technology called Claude that they have 100,000 contexts, which sounds like, oh gosh, problem solved, right? But if you feed it 100,000 tokens, then your response rate is going to be much lower. So you still have to go through these iterations of better understanding that trade-off. But yeah, to your point, ChatGPT does not ask clarifying questions, but it's something that can be implemented pretty straightforward. Yeah, so and you also have to make the decision as to whether you want to isolate information for specific reasons. Otherwise, you really don't. You want to just put it all together. And you remember how we were talking about think about your one PDF? You can, like the pharma thing, where I'm loading 115,000 token or 115,000 chunks of data for that, and on the modern data management, we're loading about 20,000 chunks of data for that. And what we're doing kind of behind the scenes on that embedding side is we just have a whole list of documents, and then we point at websites, so we scan websites, scan URLs, read PDF files, documents, PowerPoints, pull all that text together, chunk it up, put it in Pinecone. That's what it processes through all of that. And so it's really a more the merrier on that part of it, but you may want to isolate, so that's a different kind of thing. So.
I think we have one more question.
Just to follow on, so you had switched between personalities.
Uh-huh.
Is there a function that's available, or can one be built, building on Lynn's question, that could, if you're presented with those two options, that could then switch between the personalities rather than having to do that manually?
The answer is yes, you could do that. In fact, one of the things we're looking at is hybrid multi-model, which is using different models to answer based on the type of question you're asking. And so then you would actually use the model to determine which model is the best way to respond. So in this case, you could do something where you're looking at the question and then determining which personality. But again, I don't want to distract us on, if you wanted to do what you're doing, just put it all together. Because unless there's an issue where like you have a user and they only have access to certain things, you could run the model where you query that and see which things they have access to, and then do some commingling on that as well. But I do want to, I know we're time, but I shut down this gentleman on the question earlier. I'd like to take your question. Since I shut you down earlier, I want to give you an opportunity.
Appreciate that. I think it's just in the context of like your use cases were really around data that exists. My perception is data that exists out in the internet. So can you just kind of give me a recap on like, you're talking about having to break PDFs down. It's like a one doc, I got to break into chunks. So what about like, I have a library of 1,200 contracts and I want this thing to go scan through it all. So can you just give a little bit more insight? And I think it's stuffed somewhere in this pine cone theory, but maybe a little bit more explanation.
So the short answer is if you have 1,200 documents, you pull in 1,200. We have a batch loader, right? So you point at 1,000 documents, 10,000 documents, different format documents. It's basically, you say these are the documents I want to incorporate, and they all get scanned, chunked, vectorized, put in Pinecone. That's a whole load process that happens, right? So, maybe I oversimplified a little bit, but it's like any of these types of documents. If those are documents that you want to then ask questions against, it just takes some time to do it. That's already built into the whole process, right? So like if you wanted a version of RI chat that was ABC company chat and it was against this repository, that's what we designed the solution to do. And literally if you have the documents sitting on a shared drive, you point the ingester loader on them, and then as soon as that's done, you now have a chat that answers all of those. I mean, it happens that, like the pharma thing, I thought it'd be kind of cool to demonstrate it because I knew there were going to be some, and thank you. I literally downloaded some files like disease characteristics and things like that and a couple of documents, stuck it, ran the loader. It took 30 some minutes to load, and then I had that personality. That's what it takes. So, I mean, we tried to eliminate all the fuss and muss and all of that. And so sorry to run long, but anyway, thank you so much, and I'm happy to answer
Thank you,
other
Mark.
questions. So.
Thank you. Great job.